Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d square y by dx square plus dx by dy by dx equals to x square plus 2x plus 4. Firstly, let's find the order and degree of the given differential equation. Identify the highest derivative. Here d square y by dx square is the highest derivative, so order will be 2. And the highest power of the highest derivative is our degree. Degree is 1. Right? So now let's write the given differential equation in operator form. Solution: given differential equation d square y by dx square plus dy by dx equals to x square plus 2x plus 4. We know that d is a differential operator, then d square will be d square by dx square, right? Now we can write d square y by dx square as d square y plus, we'll write dy by dx by as dy equals to q x square plus 2x plus 4. Now take y common from the first or two terms of LHS. We'll get d square plus d into y equals to x square plus 2x plus 4, which is in operator form. F of d into y equals to q, right? Where f of d equals to d square plus d and q equals to x square plus 2x plus 4. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation, right? Or this one you can consider it as non-homogeneous equation, right? This is non-homogeneous equation. By taking RHS to 0, we'll get f of d into y equals to 0, which is the homogeneous equation of the given non-homogeneous equation, and we'll find yp using 1 by f of d into q, right? Fine. So let's find yc using auxiliary equation. We know that the auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square plus d, right? So let's replace the differential operator by m, so that we'll get f of m equals to m square plus m. Then our auxiliary equation becomes m square plus m equals to 0. Now take m common from the two terms, we'll get m times m plus 1 equals to 0. Now equate each factor to 0, then we'll get m equals to 0 and m plus 1 equals to 0. So here m equals to 0 is one root, and from m plus 1 equals to 0, we'll get m equals to minus 1, right? So we'll get two roots, m equals to 0 and minus 1, which are roots of, therefore m equals to 0 minus 1 are the roots of our auxiliary equation, which are real and distinct, or real and different, we can say, which are real and distinct, right? Now let's write complementary function. We know that when two roots, say m1, m2 are real and distinct, then our complementary function looks like c1 e power 1 root into x plus another constant into e power another root into x. Now our complementary function will be complementary function y is equals to c1 e power 1 root, say 0 into x plus c2 into e power the another root minus 1 into x, which is equals to c1 e power 0x is 0 plus c2 e power minus x. We know that e power 0 is 1, right? Since e power 0 is 1, so that you'll get c1 into 1 plus c2 into e power minus x, or c1 into 1 is c1 plus c2 e power minus x, right? Therefore, y is equals to c1 plus c2 e power minus x. Now let's find particular integral. We have yp equals to 1 by f of d into q. For f of d, d square plus d into q, x square plus 2x plus 4, right? So now we have yp of 1 by f of d into x power k form, right? So firstly, let's find, since we are having here x square is the highest power, I can say, right? X square. So we'll get derivatives till d square. Okay, let's see. Firstly, let's find derivatives of q. Derivative of x square plus 2x plus 4 equals to derivative of x square with respect to x is 2x plus derivative of 2x with respect to x is 2 plus derivative of a constant with respect to x is 0, which is equals to 2x plus 2. Now let's find d square of q. D square of q is derivative of q. We already have the value of derivative of q, which is 2x plus 2 is equals to derivative of 2x is 2 plus derivative of a constant is 0, so this is equals to 2, right? Now let's find d cube of q. Which is equals to derivative of d square of q. We have the value of d square of q, which is 2. So now let's find derivative of a constant, which is 0, right? So d cube of q is 0. So from here, we'll get all the derivatives 0. D power 4 of q is 0. D power 5 of q is 0, and so on. You'll get zeros, right? I mean, in general, d power k of q is 0 for k equals to 3, 4, 5, and so on. Right? See, as I said earlier, only we can apply derivatives till d square. Now, coming to yp is equals to 1 by, now take the lowest degree term common, okay? Or you can just write the terms as in ascending order, d plus d square, okay, for our convenience. Now, take d common so that you'll get d times 1 plus d into q. Now we can split this fraction as 1 by d into 1 by 1 plus d, right? We know that 1 by 1 plus x can be written as 1 plus x whole inverse. So we'll write 1 by 1 plus d as 1 plus d whole inverse. Now our yp becomes yp equals to 1 by d into 1 by 1 plus d into x square plus 2x plus 4, which is equals to 1 by d into, we can write 1 by 1 plus d as 1 plus d whole inverse into x square plus 2x plus 4. Now we can expand this using binomial theorem. We know that 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on, right? Now let's expand 1 plus d whole inverse, which is equals to 1 minus d plus d square minus d cube and so on. Now we know that till d square cube will get values, right? So we can neglect higher order terms from cube, right? So we'll use formula till 1, 2, 3, the first 3 terms. Okay, fine. Now this becomes yp equals to 1 by d into 1 minus d plus d square of x square plus 2x plus 4. Okay, neglect higher order terms from d cube, d power 4, so on, right? Since d power k of q is 0 for k equals to 3, 4 and so on, right? This is the reason why we are neglecting higher terms from d cube. Now our yp becomes one by d into 1 into q is x square plus 2x plus 4 minus derivative of q plus d square of q. Right? Is equals to 1 by d into x square plus 2x plus 4 minus derivative of q is 2x plus 2 plus d square of q is 2, which is equals to 1 by d into x square plus 2x plus 4 minus 2x minus into plus minus 2 plus 2, right? Here minus 2 plus 2 gets cancelled, minus 2x and plus 2x gets cancelled. Is equals to 1 by d into x square plus 4. We know that 1 by d is an integral operator. So we'll just remove the brackets firstly. Now we can write 1 by dx square as integral x square dx plus integral, write 1 by d4 as integral 4 dx. Now let's take the constants outside the integral. We'll get integral x square dx plus 4 into integral dx, which is equals to integral x square dx is x cube by 3 plus 4 into integral dx is x. Therefore, yp equals to x cube by 3 plus 4x. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, we have yc, c1 plus c2 e power minus x plus yp, x cubed by 3 plus 4x. Therefore, y equals to c1 plus c2 e power minus x plus x cubed by 3 plus 4x is the required solution. This completes the problem. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.